Now we want to do the operation 2 over x minus x over 2. It's clear everybody, I think, was on track with the idea that we need a common denominator here, and that the common denominator is 2x. We simply know when we add two fractions, we have to have a common denominator, and then we can add the numerators. Okay, well, we have denominators x and 2, which means that 2x is a fairly obvious common denominator. So, we have 2 over x. We want to express that with the denominator 2x. Now we can verify that 2 over x is 4 divided by 2x, because if we divide 4 by 2, we get 2 over x. So clearly this is true. How do we discover this, or how do we do this? Well, we start with 2 over x, and we multiply it by whatever is necessary to get a 2 in the denominator. And that would mean that we have to multiply by denominator 2, since we need to multiply by 2 in order to get 2x in the denominator. Now we have to also multiply the numerator by the same number, so we're going to get 4. Why do we have to multiply numerator and denominator by the same number? Well, we have 2 over x. We want this expression to be equal to 2 over x. If we multiply 2 over x by 1, then we do get something that's equal to 2 over x. And 2 over 2 is equal to 1. So we're simply multiplying by 1 in the form 2 divided by 2 in order to get a form that we can add to the form we're going to get for this one. In other words, in order to get a denominator that will match the denominator we can get for the next expression. So, what do we do with x over 2? Well, we got x over 2, we need a 2x in the denominator. What do we have to multiply 2 by in order to get 2x? We have to multiply it by x. Now we can't just multiply the denominator by x, that would change the value of the fraction, but if we multiply by x over x, we still get 2x in the denominator, but we haven't changed the value of the fraction. Why not? Because x over x is equal to 1. And of course, if we simplify x squared over 2x, what do we get? We get x over 2, which is what we started with. So we confirm in many ways that what we get here is equal to the x over 2 that we started with, and that what we get here is equal to the 2 over x that we started with. So, well, we now work through the equation. We say, okay, we got 2 over x minus x over 2. We multiply 2 over x by 2 over 2 to get a denominator 2x. Numerator will be 4. We multiply x over 2 by x over x in order to get the same denominator 2x. And of course the numerator has to be x squared. So now we have 4 over 2x minus x squared over 2x, which is 4 minus x squared divided by 2x. Now if we could factor 4 minus x squared, and of course we can, and match that with a factor of the denominator, we'd have a little more simplifying to do, but that's not going to be the case here. So we can just leave the expression in this form, unless we're asked for the completely factored form, in which case we would go ahead and factor the numerator. And of course, if we have more work to do with this expression, additional operations to do on the expression, we might well need to factor the numerator in order to continue. But in this case, we're done. Okay, what about x minus 3 over x plus 4 plus x plus 4 divided by x? Well, common denominator is x times x plus 4. In order to express x minus 3 over x plus 4 with this denominator, we've got to multiply this term, x minus 3 over x plus 4, by whatever it takes to get this denominator. In this case, we have to multiply by x so that our denominator will be x plus 4 times x. Once more, we have to multiply by x over x so we don't change the value of our fraction, but we clearly get this. And then to change x plus 4 over x to a fraction with this denominator, we're going to have to multiply the denominator by x plus 4, meaning that we'll also have to multiply the numerator by x plus 4, again, so we don't change the value of the fraction. And we then clearly get x plus 4 times x plus 4 in the numerator, and x times x plus 4 in the denominator. Now our denominators match, and we can add our numerators. Okay, we can expand x minus 3 times x to x squared minus 3x. Actually, I said now we can add our numerators. I'm going to do another step, and then I'll add the numerators, okay? I'll multiply things out in each numerator. We get x squared minus 3x here, and we get from this numerator x squared plus 8x plus 16, as you can easily verify. Now we can add the numerators. We could have done it before. I just chose to multiply them out before I added them. We add the numerators. We get x squared minus 3x, and we get x squared plus 8x plus 16. We add those together, and we get 2x squared plus 5x plus 16 over the common denominator x times x plus 4.